Okay, let's look at an example. Try to apply Rolle's theorem here. So the examples usually go like something like this. So verify Rolle's theorem for a given function. In this case, the function is f of x is equal to x to the fourth minus x squared, and on an interval minus 2, comma 2. What does verify mean? It means that given that the conclusion of Rolle's theorem is that the values of f at two endpoints are the same, then there's a point in between such that f prime is equal to 0. You're asked to find that point if, of course, the hypothesis of Rolle's theorem are satisfied. So what is the solution? First, we need to check that the hypothesis of Rolle's theorem are met. So check the hypothesis. So what do we need? We need to make sure that f minus 2 is equal to f of 2. And this is trivial here because f of minus 2 is equal to minus 2 to the fourth and minus 2 squared. But since we're racing to even powers, then this is going to be just the same as 2 to the fourth minus 2 squared. Minus 2 squared is the same as 2 squared. It's going to be 4. So this is just this is just equal to 12. Okay. Yeah. So yeah. Okay. So this is the value. We're just checking the values at the endpoints are the same. So we just check that. So now we need to find a point that satisfies the conclusion of the theorem. So the theorem tells us that if you assume that f is continuous here and differentiable inside in an interval and differentiable inside, then if you have the f at the endpoints, f at one endpoint is equal to f at the other endpoint, and there's a c in between such that the derivative vanishes at that point. So we need to find that point. Do we need to check anything else about this polynomial? No, I mean polynomials are differentiable everywhere, and that means continuous. So it will certainly be continuous. F will certainly be continuous in minus 2, 2, including the endpoints, and it's going to be differentiable inside because it's actually differentiable everywhere. That function is differentiable everywhere, being a polynomial. Okay, so now we need to find. So verifying means that we need to find C in between minus 2 and 2 such that f prime at C is equal to 0. How do we know this is possible? Well, the theorem tells us that that's where we're asked to verify it. We'll always be able to answer this kind of question because there's a theorem that tells us that this is always possible once you know that the values of f at the endpoints are the same. Okay, so let's try to solve this equation. Let's try to verify this property. So what's the derivative of f? It's 4x cubed minus 2x, and we set this equal to 0. So, but this can be written as 2x times 2x squared. No, yeah, 2x squared minus 1 is equal to 0. And then we can write this as 2 x times square root 2 x minus 1 square root 2 square root 2 x plus 1 is equal to 0. So we have 3 roots, one coming from each factor. So critical points, what are the critical points here? Critical point are x equals 0, x equals minus 1 over square root 2, which comes from the third factor here, and the second factor yields 1 over square root 2. Okay, but the theorem tells us there's a value of value c inside the interval minus 2, comma 2. So are these points inside the interval? So 0 is in minus 2, comma 2. What about minus 1 over square root 2? Is that in the interval minus 2, comma 2? Yes, it is. Minus 2 is definitely smaller than 1 over square root 2. In fact, this fraction here is minus 0 point something, because square root 2 is bigger than 1. And also 1 over square root 2 is in minus 2, comma 2 for the same reason. 1 over square root 2 is smaller than 2. And then we've actually found 3 points. So C, all these points belong to the interval. So C 0 or minus 1 over square root 2 or 1 over square root 2. They all satisfy the conclusion. They'll verify the conclusion of the overall theorem. So or all valid values for the conclusion of Rolle's theorem. So whenever you're asked to verify Rolle's theorem, you need to check that the values at the endpoints are the same, and then solve f prime equals 0. And just keep the points that are in the given interval.